Welcome in Darkcore. In our previous video, we discussed the Betelgeuse companion star. However, after this video, Dr. Steve Howell, a senior research scientist at NASA, emailed us and shared some insights and updates about this topic. In July, using the Gemini North telescope in Hawaii with the ALEX speckle imager, a NASA team detected a faint star right where models predicted. This observation explains the strange brightness cycles. The evidence is not yet conclusive, but it's the strongest indication so far that it is part of a binary system. Keep watching to get the latest updates about this topic. The discovery hints of a hidden partner have surrounded Betelgeuse for decades. Its unusual brightness changes beyond the expected pulsations of a red supergiant suggested the presence of a gravitational influence. Astronomers modeled the possibility of a companion, but the giant's brilliant glare and extended atmosphere made direct detection nearly impossible. That changed in mid-2025. A team led by Steve Howell of NASA has used Gemini North's ALEX speckle imager to take thousands of rapid exposures of it. Instead of one long blurred image, these short snapshots were combined to reconstruct a sharp view. The method allowed astronomers to separate the star's blinding light from nearby sources. In the processed images, they identified a faint point of light exactly where model-predicted companion should be. Initial analysis suggests it could be a star with a mass somewhat larger than the Sun's, orbiting at a distance comparable to Jupiter's orbit around our Sun. But because Betelgeuse outer layers extend so far, this means a smaller star is embedded deep within the giant's atmosphere. The statistical confidence is modest, which is why the team describes a finding as probable rather than confirmed. More data are needed before declaring certainty. Still, the alignment between theoretical predictions and the observed position is striking. To reflect its place in the story of Orion, the team proposed a nickname, Sawaraha, meaning her bracelet in Arabic. Betelgeuse itself has an Arabic-rooted name, and a suggestion connected discovery with a long cultural history of this famous star. While not official, the name captures the sense of a hidden adornment circling one of the sky's most recognizable giants. For now, astronomers are cautious. This faint detection could still be explained by other factors, but the evidence marks the strongest case yet that it is not alone. Scientific importance and theories that the detection is confirmed, it answers a long-standing question. What drives Betelgeuse's 6-year brightness cycle? Beyond its natural pulsations, the star brightens and dims in a slower rhythm that has puzzled observers. A companion star in orbit provides a natural explanation. The gravitational interaction would cause changes in the red supergiant's extended envelope, producing the observed pattern. The presence of a companion also changes how we think about Betelgeuse's evolution. Red supergiants are rare, massive stars near the end of their lives. Many exist in binary systems where interactions shape their fates. Material can flow between the stars, winds can be altered, and orbital decay can lead to engulfment. If it truly has a partner orbiting within its atmosphere, the interaction is already reshaping its late-life behavior. The companion itself seems to be a relatively normal star, about 1.5 times the Sun's mass. Earlier speculation that Betelgeuse's partner could be something exotic, like a neutron star or black hole, is no longer supported. Observations in X-ray and ultraviolet bands show no evidence of such objects. Instead, the data suggests an ordinary star surviving in extraordinary conditions. That survival may be temporary. On timescales of around 10,000 years, orbital decay is expected to bring the smaller star closer until it merges with Betelgeuse's envelope. Whether engulfment happens before it explodes as a supernova is an open question, but either way, the outcome will be dramatic. Understanding this interaction is more than an academic exercise. Betelgeuse's eventual supernova, when it happens, will be visible from Earth even in daylight. Knowing whether a companion is present changes models for the explosion and its aftermath. It may determine how much material is ejected, what type of supernova we see, and how the remnant evolves. Implications and what comes next. The immediate priority is verification. The current detection is promising but not conclusive. Fortunately, astronomers know when conditions will be best for follow-up. In November 2027, the orbit will place a companion at its widest separation from it, making it easier to detect with greater certainty. Observatories are already preparing for that window. Gemini North is likely to play a central role again, but other high-resolution facilities may also join the effort. Confirming the companion would turn a tentative signal into a landmark discovery. If confirmed, the system becomes a valuable case study in how massive stars live and die. It would provide a nearby laboratory for testing theories of binary interaction, stellar winds, and mass transfer in extreme conditions. Astronomers could refine models not only for it, but also for other red supergiants such as Antares. The discovery also highlights the capability of modern techniques. Speckle imaging, once thought too limited for bright extended stars, has proven powerful enough to reveal details hidden in plain sight. The method may be applied more broadly, opening the door to detecting companions around other difficult targets. Culturally, the finding deepens Betelgeuse's story. For centuries, it has captured human imagination as a bright, unpredictable star. Its dramatic dimming in 2019 reminded the world that the heavens are dynamic. The proposed name Sewara adds another layer, linking a modern scientific achievement with the linguistic heritage of the star's name. Looking forward, astronomers will continue to refine models of Betelgeuse's final stages. Whether the companion is eventually engulfed or survives until the star's supernova, its influence will be central to the outcome. The discovery may not tell us exactly when it will explode, but it ensures that when it does, we will understand far more about how such events unfold. Outro astronomers may have finally spotted Betelgeuse's long-suspected companion star, thanks to Gemini North's powerful imaging. While not yet confirmed, it's the strongest evidence that this red giant is part of a binary system, an answer we may get by 2027. It still holds secrets, and this discovery brings us closer than ever. Stay tuned with us for the next chapter in Betelgeuse's story. Thanks for watching. Cool.